Today we're going to learn how to package up our code into functions in Python. Up to this point, we've been using the building blocks of programming, but we haven't used any of the ones that combine the smaller blocks into bigger building blocks, and functions are going to be the first one of those that we're going to learn about today. Before we dig too far into functions in Python, I want to first take a look at functions in mathematics and how we can transfer that into a function in programming, and then we'll look at the similarities and the differences. We're going to use a combination of a script file and also the REPL today. And we're going to use the file in order to write our functions, and we'll use the REPL so that we can run them easily. So I'll show you a few new things when we do that. So we're going to open up Atom and create a functions.py. In here, I'm just going to create a comment, and we're going to talk about a math function. So in math, a linear function would be something like f of x equals x plus 1. And what this function is saying essentially is that the name of the function is f. It takes in an argument of x, and then it will produce an output. And so whatever you pass in here would be used here, and then the output would be equal to this. That's essentially how functions work in programming languages too. So what we're going to do is we're going to take what we have here and we're going to rewrite this in Python. To declare a function, we use a keyword of def. And then we give the function name, which in this case is f, and then parentheses, and then the arguments. And then afterwards, we have to put a colon here. From here, we'll hit enter, and then it indents itself. Remember, Python is white space dependent. And then we write our function body in here. So x plus 1 is our function body. And we'll save this. Notice that it put a blank line afterwards, and that comes down here and then backs out the indentation, and that says that this function is completely defined. In order for us to run this, what we're going to do is we're going to do something a little bit new in the REPL. We're going to docker run --rm--it, which this is all things we've seen before. We're going to share our current working directory into user src. We'll set our working directory to user src. We'll run Python 3.5, and we'll just let it go right into the REPL. Now that we're here, we need to actually load the file into our REPL, and we'll use exec, and then we'll say open, which these are functions you've never seen, and you don't really need them besides doing this. We'll pass in the string that is a path to functions.py, then we'll say read and call that function, and then we'll close this off. And now we should have an f function, and then we can pass things into it, but it didn't give us anything out. And just to make sure that we're doing the right thing here, this will give us an error because it expected the argument of x. So it is running our function, but we expected it to return something to us. It should have given us a 2. So let's go back to our code and see why it didn't. And in mathematics, all functions have an input and then they also have an output. So this would always be evaluated and be the output of 2. But in Python, it doesn't quite work that way. You can have functions that do a bunch of things, but they never actually return you anything. So for us to get this 2 back, we'll use the return keyword. So if we save this and we come back over here and we run this exec line again, it'll reload our code. And then if we run f of 1, it'll give us 2 again. So that worked. This is all it took to translate this mathematics function into a function in Python. There's def, which is how we're going to create any function in Python. And then in this specific case, we wanted to return something, so we had to use the return keyword. That's great for a single line function that we would find in mathematics. But in our case, we want to package up like actual complex logic. So to do this, we're going to use an example programming problem that's sometimes used in interviews for programming positions called Fizz Buzz. So Fizz Buzz, and what this is I'll just write the rules here too, is you put fizz to the screen if a number is divisible by 3. We'll print buzz if the number is divisible by 5. Then we'll print fizz buzz if it's divisible by both. Otherwise, we're going to print the number itself. We'll do this with a single function, and normally what it does is you take a list of numbers and you go through each number and do this accordingly. So we'll say def fizz buzz, and we want this to take a limit, and this limit is going to be used so we know where to stop. So we want to say, oh, how about we fizz buzz over the numbers from 1 to 10 or from 1 to 100. This will allow us to pass in a different number, and the function will behave slightly differently every time. So we put our colon there and we open this up, and now we're going to write a loop like we learned about last week. So for num in, this is going to be a new thing for us though, is we're going to use a function called range. Then we're going to say we want to start at 1 and go until limit. And then what range does there is it actually creates essentially a list. It's a sequence, but from 1 until limit. And so it'll have 1, 2, 3, 4, 5, 6, et cetera, until whatever limit is, but not including limit. So if limit is 20, then the last number that we're going to have in the actual sequence is 19. This is way easier than us going and manually creating a list from 1 to 100 if the number we wanted was 100. One of the beautiful things about functions are that there's often more than one way to write a function, but Python has this idea that there's probably one best way to write a function. I didn't look up what the best way is to write fizzbuzz in Python's opinion, but this is just one way we could do it. So we're going to have an output variable that's going to be an empty string, and then we're going to say if num is divisible by 3, which just means that if you do modular division with 3, it should always equal 0 because it divides cleanly. Then we're going to say output is going to be plus or equal to fuzz, which just means we're going to set output to actually equal fuzz at this point. We'll say num mod 5 equals 0. Then we'll add even more to it, and by adding buzz. And then this last line here, what we're going to do is we're going to say print output or num. And this goes back to our Boolean logic episode where we talked about what is and is not truthy in Python. And remember that an empty string is technically false. So in this case, if the string is still empty by the time we get to this print line, then it's actually just going to use the number as the argument to print. So let's save this, and we'll come back over here and reload our function here. Fizzbuzz, and we'll just do 10 just for the short version. You can see that we have 1, 2, oh, whoops, I misspelled it. Now we have fuzzbuzz, but yeah, let's come back over here and fix this. Fizz, we'll save it. Rerun this. So if we fizzbuzz 10, 1, 2, fizz, 4 buzz fizz, because 6 is also divisible by 3, up to 9, which is also divisible by 3. That's fine, but our one example case was going to be 15 is the first number that pops up that's divisible by both 5 and 3. So let's make our limit 16, and you'll see that 15 does in fact get a fizzbuzz. So this is our first real bit of Python. I mean, we've written quite a bit of Python up to this point, but this actually combines a lot of the things that we've learned about up to this point. We have loops, which we learned about last week. We have ranges, which we just learned about right now. We have comparisons and conditionals and string manipulation, printing, and then even more conditionals down here. So there's quite a bit going on. And this is where functions become pretty amazing. We can take this bit of knowledge and say that there's some more complicated thing I want to do. I can say, okay, I know how to do this. Let me write this down. And then I can share this with other people and say, oh, I have a function that does that. Here's what it is. And then they could use it. Or in this case, say I want to fizzbuzz all over the place. I can call it, with 5, or I can call it with 15, or I can call it with 1,000. It doesn't really matter. I only had to write the function one time. Now that we have this one more complicated function, let's expand on this a little bit and learn a little bit more about how we declare functions in Python, because there's more that we can do than just def fizzbuzz limit here. So we're going to create a new fizzbuzz, and this is going to be fizzbuzz2. And this one is we're going to say limit is equal to 20. And then it's going to be exactly the same. So what we're actually going to do here is just call the original fizzbuzz from inside of here and just pass limit in. So let's save that and come up and reload and run fizzbuzz2. And we're going to run it without any arguments at all. And it goes and does everything up to 20, so it hits a 19. And that's because we defined a default argument here. And that means if we do not define a limit, it'll always be 20. But that doesn't mean we can't define our own limit. So we can set this back to like 5. And now it'll only go up to 5. So default arguments are great if you know that the 95% use case for something is going to be passing in a very specific value. Otherwise, you can let somebody customize their own thing. All right, we're going to create one more version of Fizz Buzz just to show off a little bit here. And so this is going to be Fizz Buzz 3. And for this one, we're not going to have a default argument, but we are going to have 2 other arguments. So you can have more than one argument to a function in Python. So we're going to have an argument called fizz that's going to default to fizz. And then we're going to have an argument called buzz, which is going to default to buzz. And then we're actually going to copy this, the function body from up there. Whoops. Back that over. And then instead of doing fizz right here, what we're going to do is our variable fizz, and then we'll just combine that with an empty string so that it'll actually say fizz space buzz instead of no spaces. And then we'll say buzz here too. So if we save this and we come over and we reload our functions and we call fizzbuzz3, we're going to need to give it an argument again. And this will work. But we can also say, what if we want buzz to be boom? Now, everywhere where it was going to say buzz, it said boom, but we didn't change fizz, even though fizz was the second argument in our list. But we don't necessarily need to do it that way either. We could say 10 and A and B, and this would sub out everywhere where we would say fizz, so numbers divisible by 3, we'll put an A. Everywhere we would say buzz, we will put B, numbers that are divisible by 5. But there's a few other variations that you can do with this. So we can say fizzbuzz3 fizz equals red, and limit, which is usually the default, or the first argument that doesn't even have a default, we can set that to 20. And this will work too. So these are what are known as keyword arguments in Python. Every variable that is used in the declaration of a function has a name that we've given it, and you can reference that when you're calling the function through its keyword and setting a value to it. So this is all I'm going to show you about functions right now. There are a few more things that we could do with our function declaration that we're not going to get into right now, like having an optionally long list of arguments to our function, but that's a little bit more complicated. And this is like the 95% use case of a function though, and this will get you a long way. So I hope you like this video, and that this is one of those big aha moments for really feeling like programming is powerful and something that you can do a lot with. So let me know how you're using functions, and if you could like the video and subscribe to the channel and go over to the website and subscribe to the newsletter, I'd really appreciate it.